Okay, good morning again. Last time we were in chapter 7. We started talking about the 16F877A microcontroller, and we showed how the pin layout is different than the 84A microcontroller, the 40 pins. And then we talked about the architecture, the general architecture, how it looks. And then we started talking about the program memory. And we explained this in detail, the program memory, how it's made up of 4 pages, page 0, 1, 2, 3, and the address range for each page, which covers 2 kilo locations, 2048 locations. And the last thing we were talking about is how to move between pages in your code. If you forgot anything and you need to catch up, you can watch the recording later, okay? We were talking about address 20. Address 20 in page, let me go just copy, this screenshot and it may look better. ماشي خليني أخذ هاي. Better than my drawings. Okay, and put it here. So we were talking about that the program memory now in the 84A microcontroller, it was 1K, okay, but the address space was for 8K. In the 77A controller, the address space is 8K and the actual implemented memory is 8K, but the implementation is in terms of pages that is 2K each. 2K each. Okay, this is the program memory. And these numbers, we computed them, right? We did them in detail. Okay, now we know that any instruction in assembly, a go-to instruction or a call instruction, you can give it an address that is 11 bits. Okay, while this address is 13 bits. Okay, and this is shown in the program counter, which is from 0 to 12, 13 bits, 13-bit address. So each address of a memory location in the program memory is 13-bit. And the stack is also 13-bit to be able to push the whole program counter in it. While the actual program memory width is 14-bit, which means the instruction size is 14-bit. Right. But the assembly instructions can access 11-bit out of these 13-bit. Okay, so if you are at address 5 here, and you say go to 0x20, you're gonna go to address 20 over here, 0x20 over here, right? And execute this instruction over here. Like, what if I want to cross the boundaries and go to address 20 in page 1 or 2 or 3? I don't have access to the most 2 significant bits. And last time when we explained that the most 2 significant bits are the page number actually, right? So when we page the 13 bits, we have 11 bits for the 0x20 hex, but the most 2 bits out of the 13 are either 00, which is 0, so page 0, or 01 for page 1, or 10 for page 2, or 11 for page 3. So I need to be able to change the bits 12 and 13, okay? The normal instructions, the call and go to, do not have access to bits 12 and 13. So how do I change them to be able to move to and go to execute code at different pages? Okay. To answer this question, we need to look at how the program counter is mapped. So how the program counter, which is 13-bit. So let me draw the program counter over here. The program counter, PC. It is 13 bits. You have access to the first 11 bits through go to or call, right? But the most two significant bits here, 2 bits, which are the page numbers, no assembly instruction has access to these 2 bits. الآن, we know for a fact that in the data memory, the program counter is mapped to special function registers. So if I go to the data sheet and look at the data memory here, طيب, okay, هون في banks, بس okay, let me show it in for the 84A until we get to the banks. So we have this data memory, صح? Bank 0, bank 1. We know about this register, the PCL program counter low. This special function register is mapped to the lower 8-bit of the program counter. We have a register called here at address 0A called PC latch, okay, program counter latch. And this is mapped to the remaining bits, yani bits 9 and above of the program counter, okay, but indirectly. Let me explain that. So we have 2 registers involved here, PCL and PC latch. Let me explain that. ماشي? So bits from 0 to 7 هذول are mapped to a register called program counter low. So if you write something to PCL, PCL is address 2 in the data memory. So if you go just write at address in the data memory, just address 02, write anything here, it will be reflected into here. ماشي? So we know how to access the first 8 bits manually. And at address 0A on PCL, we have a register called PC latch, which is also 8-bit. But we know that this whole program counter thing is 13-bit. So the first 8-bit are mapped to the PCL. So the remaining bits are how much? 5 bits, right? 5 bits. We cannot write them directly. However, these 5 bits can be accessed through the PC latch register. But it's not like you go write something here and it's directly reflected here. No, it's not like that. Whatever you write in the PC latch will be reflected into these 5 bits after you write PC low. واضح؟ يعني لأنه أنت you cannot write a single program to say okay I want مثلا خلينا نعمل المثال اللي كنا نحكي فيه. Let's do the example we were talking about. I am at page 0 and I want to go to address 20 in page 1. ماشي? And I am here, somewhere here, at let's say at address 20. Come on. Okay, I want to say go to here. go to X, and X is here. ماشي. And the address 20 at page 0, we did the math last time, right? So the first 11 bits are 0, 0, 0, 0. This is for the 0. Then the 2 is 0, 1, 0, 0. هاي صاروا 8 صح؟ 8 bits. 9, 10, 11, right? The 20 then, the 20 is actually 0x0, 0 to 0. While the 20 here is 0, 0, 0, 0, 0, 1, 0, 0, height 2, and this is the 0, 20. Now we have 0, 0, 0, 1, 0. So these are 8, 9, 10, 11 bits, and the last 2 bits are the page number. Because we're in page 1, this will be 1, 0, 1. ماشي. And then this address 20 is actually what? 0, 2, 8, 0. So the address is 0x0820. So imagine I want to go to here. What do I write? ماشي. I want to go here. So if I say go to 20, I'm gonna go to my place. I'm not gonna go to the other page. So this is not gonna work. The go to is not gonna work. We can say move lateral to W, the first 8-bit, 20, and then move W to memory, to F, or move F, I think it was, W to F, 0x02, اللي هو this location, PCL. The result of this execution will immediately make program counter go point to this. It's like, يعني, those are equivalent to the go to. So I'm not going to be able, the instruction to change the 5 bits here is not going to be accessed if it's written directly after it. So that's why they made this latch register. That's why they made this latch register. You write to it, nothing happens, but it reflects to the most significant 5 bits after you write the PCL. So you need to write this first. You need to write the PC latch first. So this is not going to work. So to be able to go here, we need to say move lateral to W. What? The 5 bits, the most significant 5 bits, which are these one, right? These 5 bits, I need to move them where? To PC latch. So I say move lateral to W 0x. This is 0 and that is 8, 0, 8. And then I move W to F to the PC latch. And you can write its address in here, 0x0a, I think. Now these 5 bits are here, but the program counter, well, they're not here. They are in the register called PC latch. PC latch. Okay, they will not be reflected to these 5 bits until you write the PC low. Okay, they'll say here, latch. It's a latch. So you move this to the latch. Nothing changes for the program counter. The program counter stays as is. These are the lower 8-bit, and these are the higher 5-bit. So nothing happens. Then you say, go to, not go to, move lateral to W, the lower 8-bit, which are هذول 0x20. Then move W to F to the program counter low اللي هو فيها الحالة 0x02. Now, once you do this, the moment you do this, This, what you have in the latch اللي هم 0A will go be will 08 اللي هم طبعا physically هو راح ياخذ the lower 8 bit منهم اللي هم 00010 هاي اللي هم 5 lower 5 bit, and these 20 which is the 00100000. This way we wrote the whole 13 bit once in a single shot. Okay, you cannot write this 5 first, then these 8 first, because the program counter value, and if you imagine if this reflected directly to the 5 bits, then the program value changed. So it's not going to be pointing to this instruction and you cannot execute it. It's going to go jump somewhere down there in the other page. Is this clear?
سؤال ممكن ابغى اغير البيج اعمل جو تو للادرس اللي بدي اياه بدون ما اعمل بي سي ال.
Okay, and you can replace this with a go to. But this will change the lower 11 bit. تمام? The lower 11 bit. So يعني هذول. It will change the lower 11 bit. What about these two?
انا حكيت لو اني اوريدي
You
غيرت
can do it.
اللاتش.
You can do it. You can do it as this. يعني in another way, you can say, okay, I want to set these 2 bits. يعني the most 2 bits in program counter. You can do that. You can say move lateral to W. I want to make these most significant bits 1. 1. These are addressed in the PC latch. In the PC latch, the PC latch is 8-bit. 1, 2, 3, 4. 1, 2, 3, 4. Right? 0, 1, 2, 3, 4, 5. So these 5 are these 5. So you actually want 1, 2, 3, the most 2. يعني هذول. You want to make them 1, 0, right? So you can say you want to make these 1, 0. You can say bit set F, right? PC latch, bit number 4, and bit clear F, PC latch, bit number 3. And nothing is going to change on the program counter. Then you're not touching these, right? Then you say go to 0x20. هذولا 11 bit will be moved to here, covering these 11 bit, and you already made these 0, 1, will immediately reflect to the program counter higher 2 bits, 13 and 12, after executing the goto, because the goto will change the PC, the program counter low. So this could work as well. Understood? So these 3 instructions will cause the program counter to go to address 20 in page 1. Like, what if I want to go to address 20 in page 2? In page 2, يعني the same thing, but just هون بدل, let me do it in blue. Page 2, I want to make these become a 2. يعني هاي 1 وهاي 0, صح? So bit 12 اللي هو 3, I want to bit. Okay.
دكتور انت مسويها عكس.
انا عاملها عكسا اصلا. هذه كانت bit clear المفروض وهي bit set. هاي كانت, this is going to send us to page 2 بالاول بالاحمر. Now in blue you said this. طيب in page 3 I want to go to page 3. You bit set F here 4, and you bit set for both locations. You make this a 1 and this a 1, right? And you say go to 20. This will take us to address 20 in page 3 here. Clear? Surah, you asked this question. You sent me an email last night. Is it clear?
Yes, it is.
Okay. Okay. طيب
دكتور بس عادي سؤال.
تفضلي.
هلا اذا بعتنا مثلا، اذا كنا حاطين انه بورت بي يكون شغال، يعني هم لو كنا حاطين انه بورت بي يشتغل مثلا بيج 1 انه على امر معين، وبعدين حطينا امر ثاني لبورت بي نفس يعني على بيج 2، بيشتغلوا الاثنين عادي كل واحد لحال؟
No, the only one that's going to execute the one that has the program counter pointing to it.
يس قصدي انه يعني يس بالضبط، بس قصدي انه يعني
So هنا you turned on port B, you wrote something on port B here, and this is page 0, and something else you're going to do in page 1 for port B. طبعا program counter is going to, يعني we said how the program counter behaves, right? It moves sequentially, increments, unless it gets to a branching instruction and you tell it go to somewhere, and then it will execute it. They cannot be happen at the same moment.
Yes.
طيب. So the program counter, this is the explanation, يعني right up in the book, from the book of what I talked about. The program counter is 13 bits. We have a register called PCL. We can write to it directly. And if you remember the lookup table, we did the computed go-to. لما رحنا على التable, we added something to the program counter, بعدين راح رجع لنا return with literal NW. You can revise that in chapter maybe 5. And the upper 5 bits of the program counter are mapped to the PC latch. The PC latch is not going to reflect to the program counter 5 bits, most 5 bits, until after you access the PC low. The PC low, you can either directly write to it in the data memory, or you can use an instruction like the go to or the call. So the program counter, we have 3 ways of accessing the program counter. First way, the direct easy way, is using the go to and the call instructions. يعني هاي number 1. Whenever you say go to or call, you're going to access what? The lower 11 bits of the program counter. هلا هذا كلياته in red is the program counter, and it is 13 bits. A go to or a call will directly write only 13 bits. These 13 bits, 11 bits, sorry, 11 bits. There's another way to change the values of the program counter through the stack. Yani a call will push the program counter to the stack, right? A return will pop the program counter of the stack, and this is the whole program counter, the 13 bits. See, so here we're covering the 13 bits. This is the second way. The third way is the computed go-to. Okay, the computed go-to by accessing the PCL and PC latch. ماشي؟ يعني this is what we did right now here. This is what we did. This is a computed go-to. This is يعني the before this one. Here we access the PCL and the PC latch. Okay, we computed where the program counter should go. And this, through this way, by writing the PC latch first, then the PC low, and this order is very important. You cannot do the PC low first. You have to do this first, then this second. Okay? You decide the value of the program counter, you compute it. Okay? This is called the computed go-to. And by this way only, you can change the 13 bits. Okay? Other ways can only access the 11 bits. The stack can change the 13 bits, but the stack is يعني either you save the program counter or return it from a value over there in the program counter. So this summarizes it. The ways we manipulate or change the value of the program counter. Oops. By the stack transfer, واحد. By a call or go to مباشرة, and this only changes the lower 11 bit, يعني within the 2 kilo words or 2 kilo address space of the page, okay? Or by writing the PCL directly. If you want to access the 13 bits, you need to write the page number in the PC latch, then access the PCL either directly by writing to it or through the go to and call, and this will then reflect to the to bits 4 and 3 in the PC latch, which are bits 12 and 13 in the PC register. Okay. Tamam. Now, when we were talking about larger systems, we talked about, last time when we were talking about the differences between the 77A microcontroller and the 484A microcontroller. We said the program memory is different. We have pages here, and we covered this one. Then the second difference is the data memory. Now we have banks, and we looked at the status register last time, and we saw that bit number 5 and 6, if you remember, the status register in the 84A controller used to be, we used to have these most 2 significant bits unimplemented, and we had bit number 5 alone to be a 0 or a 1 to select bank 0 or bank 1. Now we have bit number 5 and bit number 6 that decide the page number. So if you remember, the data memory address is 7 bits. So 7 bits, and this is what we get from the structure here. The address is 7 bits. And we used to get the 8th bit, the bank number. It used to be a 0, 1, and they used to become 8. So an address in bank 0, address 0 used to be 0x00, while address 0 in bank 1, we used to call it address 0x80, because the bit number 8, which is the bank select bit of status register, was a 1. Now we have 2 bits. So if you want to say it, it reflects into a net address of data memory of 9 bits. But instead of adding one bank select bit, we're adding 2 bank select bits. Okay, plus 7, that's 9. And this reflects into the address range of each bank. So address, the bank 0 is 00 to 7F. Now, bank 1 will be 80 to FF, and now we will have bank 2, which is from 100 hex to 17F, bank 3, and so on. So we have now 4 banks, and these are the banks for the 73A microcontroller. 77A has more stuff. See, we have more special function registers. In the 7A controller, we used to have special function registers covering until 0B hex here, right? These were the only in the 84A microcontroller. These were the only 7 special function registers. Now see how much new special function registers we have here. PIR1, PIR2. These are for the extra interrupts. Timer 1 low, timer 1 high. Remember timer 0? We used to have timer 0 here. The chapter 6 was all about timer 0. Now we have a new timer 1, but this one is 16 bits, so it's split into 2 locations, low and high. Timer 1 configuration register, timer 2 configuration register, and these for serial communication, buffer configuration, CCP, capture, compare, PWM. All the new peripherals have special function registers we're going to deal with. So when we talk about the analog to digital conversion, we're going to deal with ADC Con 0 and another one called ADC Con 1. See, analog to digital conversion configuration register 0 and configuration register 1. And when we talk about the serial communication, we will have a transmit register, a receive register, and a serial communication. Yeah, these are the ones, configuration registers. We have extra ports, D and E. These were not there in NC even, in the 84A controller. Now they are here. We have memory locations for them and for their direction registers. Okay, and for the data memory, we used to have, I forgot, what was it? 68 locations. Now here we have 96, 96. Okay, we have much more data memory in the 4 banks. Well, when you write in assembly, you need to worry to move between banks. Now, if you're using a compiler in C, then the compiler will take care of moving between the banks. طيب. The last thing, oh wait, see, time is over. Time is over and we're not finishing. So this is the other difference. The peripherals, we talked about that we have extra peripherals, and we're going to cover these two, A to D and serial communication, parallel ports and interrupts next time. Next time. Sunday. That's yani, see, the interrupts here are different. In the old one, if this makes you familiar, these you are used to be 1, 2, 3, 4. Yani, this was different a little. The 4 sources of interrupts for the 84A controller. Now we have all these new ones. We'll talk about them next time. Thank you very much. See you Sunday in class time. And if we will have extra sessions, I'll announce it. I'll email you.
يعطيك العافية دكتور.
Thank you very much.